Hello ladies and gentlemen. So someone asked for section 7.1, number 6, and this is the one that we started looking at in the virtual classroom that I said I needed a little bit more time to think about, and I did require that time. It took me a little bit. I got the answer before I got a way of really being able to explain it. And on the AP exam, some questions are definitely like that, and certainly in the multiple choice. You can get an answer either by eliminating or by knowing the answer and moving forward, but the explanation or a formal write-up of that is a little bit tricky, and that's what we're kind of looking at here. So I'm going to go over this one. It's going to be a lot of work for a multiple choice question, but I'll try to make it as straightforward as we can. So I was looking at this, and it took me a while to really get an idea, and what I had to do was I had to stop and think about what the section was and different things that we knew were going on, and I finally decided this is all about areas under a curve. So I decided to set up, we've got our velocity over here, which is miles per hour. And you've got your time down here, which is in minutes. So already we got a bit of an issue, okay? Because we've got some unit issues happening here. Now along here, you've got 10, 20, 30, 40, 50. So I went up by 10 miles per hour. And across here, I'm going to go out by minutes. So I've got 1 minute, 2 minutes, 3 minutes, 4 minutes, 5 minutes, 6 minutes, 7 minutes. And that is this information up here, what I'm putting into a graph. Now you're used to an XY chart always looking like this, where you have your X value over here and you have your range value over here. That's not the way they're showing it. They're showing it this way, and you can understand why. They're saving an awful lot of room here. Now also in this one, instead of X, we're going to be talking about T because the function's in terms of time, right? So let's see what I have here. So at 0 minutes, I have 0 speed, and at 1 minute, I have 20 miles per hour. At 2 minutes, I have 40 miles per hour. At 3 minutes, I have 45 miles per hour. And notice all of those are going up. And that's what it's saying here when it says that the acceleration is positive between 0 and 3. So if this entire function is the velocity in terms of t, okay, this entire function that I'm drawing out here, then the velocity's derivative being greater than 0 is its acceleration, which means that the slope of v of t is going to be positive all the way up to here. Now, after this point, okay, they tell us that v of t is going to be negative, which means that the velocity is going to be decreasing, which means that the slope needs to be decreasing on this side after 3. So I need to be coming down. Now they skip 4. They skip 4. It's not in your chart. That's something that you got to notice. But we go on to 5. And we've got 35 here. So this one up here is 3, 45. And this one over here is 5, 30, 5, 35. Those are going to be the two important ones I'm going to be looking at in a minute. So I just put those values there. Then I've got 6, which is going to go up to 20. And in the context of this problem is absolutely useless. I don't need that information. And 7 goes up to 5. And again, that's going to be absolutely useless. Okay, so now we don't have data for in between the minute sections. So the best we could do is we could sort of sketch this with a nice curve, and we could say that that's probably what's happening. The other thing that you could do is point by point connect them. Now that's probably not what's happening, but that would give you an average in between them. So if you were looking at this curve, you could be looking at something that went like this. Now again, it doesn't make sense that it's going to be connected with a linear function. It's probably much more conceivable that it would be a smooth function, but it's giving me an idea of what I'd be looking at. Now the next part of the information that they give me is they tell me that everything up to here, the distance, the area under this curve. This area is going to be this distance times the height. So you're getting the velocity times the time, which is going to give you the overall distance that it's traveled. Now, if you don't have physics, one of the important things to remember is velocity equals distance divided by time. So velocity kilometers per hour, kilometers over hour. If we rearrange this, and if you multiply the velocity, so the height of the curve, versus the length of the time, then what you're going to end up is total distance traveled. So they're telling us that this is 1.25 miles up to this point. And the question is, which one of these options is possible, not exactly true, but possible up to this point here. I'm going to grab a different color. Up to this point here. So in other words, we're wondering what this area could be. Okay, so how much would I be adding to the 1.25? And we don't know. Now, this is an average between this point and this point, but the curve could actually do anything. The curve could actually be going really, 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 really. I'm gonna put a linear across here, and you're going to assume that this is at the velocity equals 45. Okay, so right across here, we know that we can come all the way out to this point, but we have to be below this line. How do I know that? Because the acceleration is negative. So I have to be at least a little bit below this line. How much? Who knows? It could be infinitesimal, but I have to be a little bit below that line. So this area, the maximum this area could be, would be this length, which is 1 minute. So in terms of hours, 1 minute is 1/60th of an hour. And this height would be 45 kilometers per hour. So, and it must be, now I said equal to, it can't equal that because we know it must come down. So it's got to be less than that. So 45 over 60 is going to be 0.75. So the well, it's not the maximum. It has to be less than this amount of miles can be added to the 1.25. And what's the lowest amount? What's the smallest area that we could be adding to this? Well, the answer is, if I was to come down to the 35. Now, I can't be 35 because I have to be decreasing all the way down here. But I could be just above 35 and just have that little bit more to fall between 4 and 5. So I must have an addition of area here that's got to be greater than that. So the area added minimum must be greater than this amount of time, which is 1/60th of an hour, and this height, which is going to be the velocity of 35, which, using my calculator, 35 divided by 60 is 0.583, approximately, miles. So that means that the total distance from 0 to 4 is going to have to be between, remember this is 1.5, we are at 1.25, so you already have the 1.25. I could add 0.583 and 1.25. I would have to add the 0.75, which has to be in between here. So we're looking at 1.25 plus 0.583, and it's going to give us 1.833. And it's got to be less than 2. So it has to be between 1.833 and 2. Let's look at our let's look at what we have to choose from. A, can't be A. B works, it's in our range. C, can't be C. D, they're trying to trick me, I know it has to be less than that. E, they're trying to trick me, I know it has to be greater than that. So the answer is B. That was a great question. I had a lot of fun with that one. I hope you did too.